Okay, so I'm continuing work on my project here, but what I wanted to do was I wanted to figure out the amount of resistance I would need for such a huge circuit, and I'm really hoping it's going to work. Okay, so I want to see if this is going to work. But basically what we figured out was that on one of the legs of this circuit, if I put a resistor in it that was, let me move this over here for a second. Um, if I put in a resistor over here that was, let me cut these guys off. If I put a resistance in here, I think it was about like 340 ohms. The light would light well. Okay. 340. Oh, I don't have it hooked up yet. Okay, whoopee. It's a little bit too much, so let's find out what the problem is. So I'm hooking up basically an ammeter to this so I can find out what's going on. And I'm going to run it. And it's getting like 20 amps, so it's a little bit too high. Okay, so I can tune it down or tune it up. It's like 350 maybe. 350 will work. Okay, that's good. See that's what I want. Now using a 350, each one of these will have 350, right? So if I go in a parallel circuit, since I'm running parallel circuits, if I say 1 over 350 plus 2 over 350, 1 over plus 1 over plus 1 over 350, if I go like this, I'll end up with like 26 over 350, right? And let me find this equation really quickly. Um, yeah, the formula that we're using is this. It's like 1 over resistance is let me see if I'll show it here. It looks terrible. Hang on a second. This is what we're looking at here, is that in a series circuit, the resistance adds up. And in a parallel circuit, this is like a parallel circuit, 1 over the total resistance equals 1 over R1 plus 1 over R2 plus 1 over Rn. Okay, moving back over to this circuit, okay, whoopee. Moving back over to this circuit, I have 26 light bulbs that I'm trying to run. Each one is going to have like a 350 ohm resistor if I was going to do each one separately, right? But I'm trying to do them all together. And what that means is that if I take 26, the total resistance I need is 1 over R total. And if it's 1 over 350 plus 1 over 350 plus 1 over 350 plus 1 over 350 plus 1 over 350, I'll have 26 over 350, okay? And if I take a calculator and do this, okay, and I go, let's see, and if I go like this and I say 350 divided by 26 should give me like 13. So if I use like something like a 14 ohm resistor here, it should work for 26 lights. It's going to blow up right now, but if I run 26 lights all together, that's what's going on. Like right now I have 322 milliamps, but what's going to happen is I want to distribute them amongst all these lovely thing. So that's what I'm going to try. Okay, so I'm still working on my circuit. I have to have it all wired up to have this really, really work. But if I try to run this right now, there looks like I'm getting lights, but they're sort of blowing up. Like what I'm trying to do is get this more, more under control. So I'm going to keep working on it. Get back with you. And I got it all wired up. It took a little while to do it, but it's all good. We're going to run the simulation now just to make sure this works. So I've got 26 lights, all running on one 9-volt battery in parallel. I probably couldn't do this in series because it's like just way too big. And I've got my, I'm trying to run this on a 14 ohm resistor. So here we go. Boom. And ta-da! Look, they work. Okay. It's good. It's going a little bit low on the amperage or whatever. We could try to make them run a little bit higher. So we can maybe go to like 10 and see what happens. 23 is too much, so we could do 12. Look at that. 12 ohm resistor. If I can find one. Not sure I could find one. That's the thing. Sometimes the resistors don't come in exactly, the thing they want. But there it is. It looks like it's possible to run 26 lights. What I want to know is I want to know your resistor and I want to see your light set up here. Okay, and what's going to happen is we'll just wire this right to the letters that we're making. Okay, so it looks like it's going to work, and I will talk to you later.